Hi, welcome to another episode of the Exciting Flutter Show. In this episode, we'll be doing some interesting things that involve text editing. Again, we'll be building on the knowledge from the previous episode where we saw how the text editing controller can be modified to paint text in the text field with different styles based on pattern matching. We'll be exploring autocompletion in this episode, and we'll build an app that has inline autocompletion. What that means is we'll be able to show autocomplete suggestions inside of a text field, and those suggestions will be painted with a shade of the actual text color, to hint that they are suggestions. And maybe we'll also add support for gestures to be able to apply those suggestions by, say, horizontally dragging across your screen. Our app will also have a custom keyboard with autocompletion, and this will just be an attempt to replicate the keyboard that we have on our smartphones today. You can see the videos on your screen. This is exactly what we are going to have at the end of this video. All right, I will show you a live demo, and then we can get to building the specifics and all of that. Okay, so this is the inline autocompletion. You can see that as I type, I'm getting suggestions in here with the suggestions painted slightly gray or a shade different from the actual text, and I can drag across my screen to apply this. Okay, and then for the keyboard demo, this is a custom keyboard. It's from scratch, a widget, a keyboard widget. And as you start typing into this, you get autocomplete suggestions at the top. All right, so this doesn't have any inline suggestions, just replicating the keyboard that you have on your smartphone. Okay, so that's that for the live demo. It's important to know here that the aim is not to be as smart as the autocompletion that we have in smartphones, for your smartphone keyboard, or even in some rich text editing interfaces, maybe your email applications. If you use Gmail, you have probably seen some autocompletions going on, co-pilots in your VS Code and other IDEs. You also see some autocompletions going on. Those ones rely on artificial intelligence, and we'll not be touching on that in this episode. What we'll be doing mostly is showcasing how Flutter can be used to make this experience possible. So not the logic of it being smart, but try to make it smart enough. But really what to see here is how you can paint this text inside of a text field to look like suggestions, and how you can use gestures to enable your users to apply these suggestions. So give them a unique experience, basically. All right, that said, let's get into the code. I have some files already. This is the main. This is the main.dat file, and here we have a Flutter app, which is a material app. We have some theme defined here for our buttons and the home page. So this is the home page, is what you see right here, has this app bar with this text, a column, and two buttons in it. And each of these buttons navigates to separate demo pages. So this goes to the inline one, and this goes to the keyboard. All right, so let's take a look at the inline demo page. This is dumb at the moment. Nothing is going on in here, just scaffold the text field. You can type into this text field, but there's no autocompletion, nothing yet. And then for the keyboard, it's the same thing, except that we have a keyboard widget. And this keyboard widget is something that I've written. That allows you to, so right now it doesn't work. So we have to hook this keyboard up with the text field, pass it in the controller, the text editing controller, so that each character or button press here can modify the text value. But yeah, this code will be available on GitHub so that you can take a look for yourself. Right now, you can toggle caps lock on and off. You can change from letters to numbers and special characters. But yeah, it's not functional for now. We'll get to that soon. I also have some other widgets here. There's a widget here called suggested text. This is what we use to show the autocomplete suggestions at the top of the keyboard. So it's here yet, but it's not in use. All right, the last thing that I'm going to show here is the trie. So in this episode, we're going to use trie for the autocompletion. So there is nothing so smart about this. No machine learning, no AI. We're not training on some data sets. What we are doing is simply using a tree-based data structure that allows us to store and retrieve text or strings from a set of data very, very efficiently. So what the trie is this tree-based data structure where you can have the root node. The root node can have multiple nodes rather, and multiple children, but each of the paths that you follow from the root to any of the leaf nodes will give you a word. So we have an example right here, and each of the paths that you follow here, from here to here, APP is a word, AT, arts, BEEB, bag, ban, bean. So this is the structure that we're going to use to store text and efficiently find them as well for autocompletion. So you can imagine as your user is typing AP, you walk down your trie to find the characters A and P and look for any other characters that closes that part. So in this case, you would find APP and then show them up as a suggestion, right? So that's essentially what we're going to be doing. All right. I have scraped some stories from the internet. I'm going to leave the links to those stories in the README of this episode on GitHub, so you can check it out. But there are about 6 stories here, and this is the text from this file is what we're going to process and feed into our trie, so that our trie can have a good enough data sets or dictionary type of thing to work with. it's going to fill in some places where you type in some words that are not in these 6 stories, but it's a good base for us to go. I have some assets here. This is the icon for the caps lock. This is the field version of that. And in our pop spec, I specified the assets that I'm using here, but there's nothing else going on except maybe the upper bound constraints for the SDK. But we're not using any new-ish feature in Flutter, so you should be fine if you set this to something lower. Okay, so let's get into it. The first thing that I would like to do is actually talk about the trie. There's going to be a different video where I will explain the trie and how to implement it in my data structure series. But from the visual explanation, we have 2 methods that we care about. The insert method, which inserts a text into this trie. What it does is it creates a node for each character and associates the following characters to themselves. So it creates a path from the first character in our text to the last character in our text, and it marks that last character as the end of the word. So whenever we are looking up words in our trie, we know where to stop or what to count as a word. And then we have the autocomplete function, which takes a prefix. So this prefix will be something that we get from our text field when the user is typing. We send it to the trie, and then we find words that begin with this prefix and send them as suggestions to the user, so they can choose to apply that or not. All right, the result of this is also sorted. You can choose not to do that, but I wanted to have, we can also choose to pick suggestions from this autocomplete search at random, but I wanted to have this result sorted so that certain words are given some priority. Okay, that said, we're just going to get into writing the code for the inline demo page, first of all. So what we need here is a text editing controller. And so I'm just going to create this. So if you followed from the previous episode, you know that we can modify this text editing controller to paint its text differently because of this method called build text span. That's the exposes, right? This is where whenever you're not doing whenever your operating system is not doing spell check suggestions, or for text form field where you can obscure characters, or when some composition is going on, for instance, whenever none of those things are happening, the painting or the building of the text span that is actually painted inside the real text field is dedicated to your controller. And this is where we can take advantage and style things differently that we want. So we can have the regular text in the controller with the regular style passed down from the text field, and then we can grab the last text that was entered into the text field and do an autocomplete search on our trie, grab the suggestions, pick one of the suggestions, and paint that suggestion with a shade of the color of the text in the text field. And then the user can drag their thumb across the screen to apply the suggestion. All right, so remember we already have a custom editing controller class, which extends text editing controller. So what I'm going to do is go ahead and copy this build text span method from text editing controller rather, and then we will override this in our code for the custom editing controller and do something with it. Okay, close this for more room. All right, so in the inline demo page, we can make this a custom text editing controller, fix the imports, and add our controller to text field. Okay, nothing has happened especially here. We just created a custom editing controller that extends the text editing controller. And the reason for this is because we want to have access to this build text span method so that we can paint suggestions along with the text in the text field. All right, so one thing that we need to do here is we need to prepare our trie. So the trie right now it's nowhere to be found. We need to create an instance of it. We also need to load our story from this text file and do some cleanups. So we don't want to have empty spaces. We don't want to have things like these special characters. We don't want to have these stories are weirdly formatted because you'll see some of them have these double hyphen marks. So we want to do a lot of cleanup here. And once we're done with the cleanup, we want to split this entire file by empty spaces, which would give us a long list of unique words. We can put that in a set so that we have unique words, so we don't have to repeatedly insert words that already exist in our trie. That would be a wasted operation because it won't be an actual insert. What it will do is just walk down. It will walk down the nodes, the parts, the known parts, and it will find out that it has no new character to add, so it will just exit, right? So to prevent that expensive operation of adding things that are already there, we can just after cleaning up the data from our story, the text file, we can grab all of the unique words and add them to the trie. So that's what we're going to do in our text editing controller. So I'm going to create a method called prepare trie. And in here we want to load the story, the text file. We can use the root bundle from Flutter services to do this. So that means we have to mark this as async. That would be load string, and we want to load assets slash story.txt. All right, after loading this, we want to do the cleanups. So we want to get rid of all of the new lines, those special characters, and all of those things. To do that, I've actually created, oh, I haven't. So let's do that. I will need to create a utility. And actually, I will just copy this and paste this to save our time. So what I've done here is define a static method called clean that takes a text, removes all of these special characters. So if we have any of these characters in our text that starts or ends the text, so it doesn't mess with them if they are inside the text. In cases where you have something like, yeah, this is not going to be cleaned. It's a valid word. But um when you have words like this, which is a start of a quotation, we want to get rid of this and just put the word in our trie. So also words that end in questions, colons, semicolons, those type of things. So here we make sure that that our text does not start or end with any of these characters. And we do this repeatedly until that condition is satisfied, then we return. Okay, so that's just one part of the cleanup that we will use in the prepare trie, but it doesn't cover all of the cases. We also need to get rid of the new lines. So we'll split by new line and replace those new lines but with empty spaces. And we also need to replace these funny looking characters because they just happen to be in these stories that I found on the internet. And once we've done that, then we can do a final split. And what we'll get is a long list of words. We can find the unique words here by using the spread operator inside of the sets notation. So this will construct a set from this list, and it will only leave us with the unique words without repetition. And so from here, what we'll do is add all of we will iterate over all of the text in this set, and we'll clean them, we'll further clean them, which is just removing all of the special characters that be start or end the word. And after we've cleaned them, then we want to insert into our trie. Our trie is nowhere to be found, so let's create a trie. Make this final. Yeah, insert this into the trie. All right, so that's that's actually everything for preparing a trie and setting it up. So we're basically creating a dictionary of words so that we can do efficient lookups later on and provide some autocomplete suggestions. We want to call this in the constructor of the text editing controller. So we prepare a trie as soon as this is constructed or when this is constructed. We probably want to make this non-blocking, but from my test, it doesn't block the UI thread. But we're not doing so much yet. But if you notice that this is blocking, then you probably want to use completers to make this asynchronous. So use a completer, you delay this. I think I should just do that in here. Maybe I should just show what it would be like. So what I mean is we're going to need to import Dart sync and show completer. Create one like void, and we delay all of this just by some duration. What I'm doing should make sense in a moment. And then here can just return the future from the completer. That means we need to make this right. And then once we are done with this processing, we can call complete on the completer. So all of this workaround is to make this an asynchronous and instead of a synchronous operation, so that it doesn't block the UI thread. Yeah, you probably won't run into this if you're trying this out on your own with the synchronous version, but if you're doing more than just inserting into a trie, for instance, I was trying out to see if I can make this more smart by doing look-aheads. So instead of auto-completing things that I'm writing, I want to also be able to see something like if I type hi, then give me suggestions for things that should follow hi. So that's going to require you to modify your trie in some way and create this relationship between the words to tell your trie which one follow which ones, which words follow each other. So that's going to be more expensive to do inside of here if it is synchronous. And this is when you would really need something like this. Okay. All right, now that we have prepared the trie, the next thing that we're going to do is create a listener that we attach to this text editing controller. So this text editing controller will be listening to text values that are typed into the text field. And the reason we want to do that is so that as soon as the user is lifting their hands or their thumbs or their fingers from the keyboard, we want to show them suggestions, if any, yeah, for whatever points they're at. So we want to attach a listener here to show those suggestions. So I'm going to create a method and call that listener. And I will also add that listener in the constructor. We should create a dispose method while we are at it. So I'm going to remove the listener in the dispose. Yes. Okay, so what we want to do in the listener is this is going to be triggered every time there is a text update. Yeah, there's an update in the text value from this text editing controller. Remember, the text editing controller is a value notifier. So whenever there's a change in this text editing value, we get notified, right? So we want to know what was the last text that was typed into the text field. We grab that last text and do some autocomplete search. We also want to debounce this so that if the user is typing, we don't make these calls to the trie to fetch autocomplete suggestions for every character that they type. So we want to wait some milliseconds based depending on the typing speed. We want to wait some milliseconds and then do a search. So here we're going to need a timer from the Dart async as well. I will, let's just create that up here. So we're going to use the timer to do the debouncing. And then let's do 200 or 250. See how this plays out, and then we can tweak this value later on. So what we want to do inside of this callback is check if the text value is not empty. If the text value in the text field is empty, then there is nothing to suggest, because we're suggesting based on what they are typing. And if it's not empty, we want to grab the last text that they've entered. Just going to copy that in here. So we split by empty space and grab the last text. So in this case, if we do that here, we're going to get two entries, two elements in this list, hi and an empty space, an empty string, right? And since it's an empty string, we don't want to do any autocomplete search. So we wait for the users to type in something else. Once they type in something like another character, then we have hi and p, and then we grab p and do the autocomplete search and show them suggestions. All right, so we want to make sure that last text is not empty. And if it's not empty, then we want to grab the suggestions from our trie by calling autocomplete. We tell it the prefix that we want is the last text. And let's set this to lowercase. The reason is many of the words in our story are actually lowercase letters, and even those that are not, we want to have more suggestions. So if you're typing, for instance, capital H and then hi, we do know there might be more words that start with HI that are lowercase than the ones that start with capital H and lowercase I. So we want to search with lowercase for all of them to get more suggestions. That's the idea here. You can take this out altogether if you have a richer data set, but this is just some constraints that I have. Okay, so for now, we're just going to print our suggestions. And I'm going to hot reload, go to the inline. It should load the trie. Let's add a message. Let's add some print statement here to know that we are done. So yeah, we can print the unique words from our story. And here we print with the trie. Okay, so these are all of the unique words in our trie from the text file. There are about 2,000 of them or more, if I'm not mistaken. Let's print the length of this. Oh, 23,000 of them. Okay, so you can see we still have some problem here with our cleanups, but for the most part, this is cleaned up nicely, and we have words that are just comma separated. And then, yeah, they are loaded into the trie. So I'll take this out, and then we'll see what we get when we start typing into the trie. Let's see if we have some suggestions. So I type H, and yeah, we do have quite a lot of suggestions. HO, HA, And these are all from the trie, from the data that we've inserted into the trie. And if I type, I have a smaller list of suggestions of words that begin with HOR. Horn, horns, horse, horribly, horseman, horror-stricken. Right, let's try something else. Let's go for PLE, and then I have these suggestions. Right, okay. So we're getting suggestions. The next thing is we want to paint these suggestions. So as I'm typing, I want to see AD, for instance, as a suggestion for auto-completion here inside of my text field, inline inside of the text field. We can decide to pick just the first element here, or we decide to do that at random. I think we should do it at random. So we're going to need the random class from the Dart maths library. Do we do that first, or do we do the painting first? Okay, let's do the painting first, and then we can try to randomize things. All right, the painting is going to be done here, but we need to keep track of our suggestion, the state of our suggestion. How okay, yeah, let's do that with a string, a nullable string, call it suggestion. So once we get our suggestion, let's make sure this is not empty, because it could be empty. Okay, I think that we can I'm arguing inside of my head. We can use the first where and then give it the or else. Yeah, let's do that. Suggestion is do we need to do yeah, we can just do first where this is not empty, or else, although or the else will need a string that is not nullable. So yeah, I guess the other voice in my head has one. Let's just check if this is empty. If it's not empty, then we want to grab the first element from the list as our suggestion. So, we also want to reset this to null every time we get new characters into our text field, so that we can trigger this again and get new suggestions. Otherwise, okay, we're already setting this to null up here, so we don't need to do any cleanups anymore inside of here. Move this up. And yeah, we have our suggestion. The next thing is to actually paint it. If you remember from the previous episode, where we should focus on when we are painting stuff, and we don't want to mess with composition, spell check, suggestions, and the rest of that. We want to do that inside of this if block when composition region is out of range. Okay, so the first thing I'm going to do here is check if the suggestion is not null. If it's not null, then yeah, this is where we want to return a text span that has two children. So the first child is going to be a text span that contains the text in our text field, the text value in our text field, and the second child will be a text span that contains the remaining substring of that suggestion. What I mean by that is we typed in PLE. If you're going to pick the first suggestion, we're going to end up with plead. So the suggested suffix, right, is just ed. So we don't want to paint plead as the suggestion. We only want to paint ad as a suggestion. So yeah, we have to grab the remaining substring and paint it with a different shade. So that's what we're going to do inside here. So we're going to create a text span. Actually, you can just return one like so. We're going to pass it the style that we get. We're going to create children because we need those two text spans that I talked about just now. The first one reads a text in the text field, and the other one reads the suggestion. And then we style it differently. You know what? Let's just merge the styles. So that will be merge text style. Then we'll grab the color from the text style and give it some opacity. Okay, so we can already see that we're painting, let's make this 0.4. We can already see that we're painting the actual text and the suggestion. But remember, we don't want to paint all of the suggestion. We only want to paint AD because we already have POE in our text field. So how we will actually do that is here where we are setting the suggestion. All we want to do is grab a substring and we want to start from the length of our last text. All right, so what this will do is, since our last text is POE, it will just only show the suggestion from where this prefix that we sent to our trie to fetch autocomplete suggestions, where it stopped. So yeah, that's essentially what's going on here, to get the substring of this suggestion and only show the last part that is not visible on the screen. Okay, I'm going to hot restart and try this. I'm sorry. So except we refresh the screen somehow, I'm doing that manually by saving my changes and hot reloading, hot refreshing rather. You won't see the changes here. So we need a way to notify this text field in our inline demo page whenever there's a new suggestion. So just using the string is not going to cut it. We need something else. And I'm going to propose a value notifier here so that we can attach a listener on from our inline demo page. I'm going to call this the suggestion notifier and set this to, okay, so I want this to be, yes, a value notifier whose value is initially null. I am going to expose a getter for this, and this getter is what the UI side will listen to. And then we can modify our code to use the notifier. Also, dispose this in the over reading dispose method. Okay, so now that we've done that, we can go to the inline demo page and wrap this text field with a value listenable builder, which would listen to the suggestion notifier. And whenever there is a change, whenever there's a notification, it will trigger a rebuild, and that will show the suggestion on the screen, because it will trigger your text fields to rebuild, and the text editing controller will have to repaint the content of the text field. So I'm going to wrap this with the value listenable builder. And the value listenable is control dot suggestion notifier. So I don't actually need the suggestion from this notifier. I just need to get notifications to rebuild, because the painting is happening inside of the controller. It's not happening in my widgets. It's not happening in my inline demo page. Okay, so remember, this controller is a custom editing controller, and that's why we have access to it. And the custom editing controller extends the text editing controller, so it's compatible with your text field. All right, now we can try that again. And there we go. Captain. There we go. Okay, so we have inline suggestions. The last thing that I want to do is add some gestures so that we can apply suggestions with gestures. So I want to be able to drag across my screen from left to right, and it will apply this suggestion. So this will no longer be captain with IN grayed out, but it will just be the full word captain inside of my text field. Because if you print the value of this, the value of your text editing controller right now, it will be, this is what you get. Lead with capped. This IN is actually not part of the text value. It's just something that we are painting on top of it as a suggestion, right? See, here we are painting the actual text, and then we are painting the suggestion. So the actual text is just this one without the IN. So if we want to apply this, we have to grab this suggestion notifier's value and append it to the text of the controller. So I'm going to create a function called apply suggestion. And then in the inline demo, since I want to, the way I want to apply this is using gestures. I want to have a horizontal drag that will, at the end of that drag, it will trigger the current suggestion to be added into the text for the text field. So I'm going to create a method called apply suggestion that will take the value from this notifier, append it to the text, and then clear this notifier. And in the inline demo page, I'm going to use a gesture detector to detect that drag gesture and apply, and call this apply suggestion when the horizontal drag is over, when the user lifts their hands from your screen after doing the drag. So there you go. Okay, so apply suggestion. I'm going to do some copy pasting, save some time. So we grab a suggestion from the notifier, we append it to the text value of this text editing controller. We clear the suggestion notifiers value, we set it to null, and then we update the position of the cursor. I will comment this out and then you'll see what happens when we don't do that. On this side, we're going to wrap our entire padding with a gesture detector. You can just wrap the text field. And then on horizontal drag end, I don't need the drag details. So we want to apply gestures on horizontal drag. So if the user drags their thumb or finger across the screen, and once they're done doing that, we just call apply suggestion from the controller. So if I try that now, yes, we've applied this suggestion and it's getting more. And if I drag again, it applies this suggestion. Right, so if you noticed what happened here, when I dragged to apply the suggestion, the cursor went back to this position instead of appearing in front of this text. If I do that again, it goes back. And that's because when you update the text value that way without updating the selection value, you can throw the cursor out of position. And this is where this line is important. So we set the base offsets for the text selection, and we set that offset to the length of the text, so it appears in front of the text. So if I type in more now, yeah, the cursor shows up where it's supposed to show instead of moving all the way to the back. So that's why this is important. All right, so we now have everything that we need for inline suggestion. We are notifying the text field to repaint whenever there's a new suggestion, and we're doing that painting from our custom text editing controller. We are also using some gestures to apply the suggestion, the current suggestion. All right, so yeah, we're actually done here for the inline demo page. Yes, we are done here. I wish I had a whistle or something I can blow to cheer myself on. Okay, so the next part that we're going to touch is the keyboard side, right? So we've achieved inline demo, inline autocomplete suggestions, and the next thing we want to do is the keyboard. One thing that we did not do here is I said we're going to randomize the selection of the suggestions that's inside of our listener. So instead of picking the first suggestion always, we can pick a random one. I think we should do that. We're going to import that smart library to grab the random class. I will create a new random instance. And here I need to know how many elements or how many suggestions that we have retrieved from our trie for the auto completion of this, whatever text that was written there previously. And yeah, so we can we need this count to be the maximum range of our random function when we call random.nextInt, right? We need that to be the max range. Okay, so random suggestion would just be suggestions at index random dot next int. The max is just going to be this count. I think it should be count minus 1. I will find out. Yes, I think. Okay, so exclusive, yeah, exclusive of this. So yeah, we're fine. We're fine with just count. So we'll grab the random suggestion and do the same thing. We need the substring. So if I restart this, I'm going to show my debug console so that we can see the suggestions that are printed out. PL E. So this is the result for PLE. And every time there is a new random completion, instead of always picking plead. So it picks randomly from this list. Pleasure, pleasures, pleasantly, plentiful, pledge, pleasuring, plebeian. Right. Okay. So with this, we have actually achieved inline painting of autocompletion. We still have the drag to apply. Yeah. So the next thing that I would want to do is the keyboard part. This will also reuse this custom editing controller, but there won't be inline suggestions. The suggestions will be showing on top of the keyboard. There will be at most 3 suggestions at a time. So we have to make some modifications to this custom editing controller because here we only have access to 1 suggestion, which is painted inline, but we want to have 3. If you remember, the autocomplete function can return multiple suggestions. So we can decide to pick the first 3 or pick 3 random ones. Sorry, I need to drink something. Right, so we can decide to pick any 3 suggestions and show at the top of our keyboard. So we have to add another notifier here, whose value will be a list of strings, and there can only be at most 3 of those strings for our keyboard. Before we do that, let's make our keyboard functional. It's dumb right now. None of these things have any effect. You can toggle caps lock on. So let's make sure that when you click on these keys, we see something go on in the text field. Okay, so the first thing that we want to do is also create a controller here, and it will be a custom text editing controller. We want to pass that to our text field. And we also want to pass that down to the keyboard so that whenever we click on any character, we can append that character to the controller, the text editing controller. So we take that in from the keyboard. And so we have to pass that here. Okay, that's private. All right, so I'm going to create a dispose method, override the dispose method, and dispose this. Now we can focus on the keyboard. So this is just some logic that toggles this. When you click on this, it changes all of the keys from the letters to numbers and special characters. This is also the logic that toggles caps lock. So when you tap on this, it turns everything to uppercase characters, and when you click on it again, it changes them back to lowercase characters. And inside of here, this is just the layout of the keyboard. There's a column, and we have some rows. The first row is this one. If you notice, we are only showing the first two rows from any of these lists, depending on whether we are showing letters or we're showing numbers and special characters. So we'll show this first two first of all. The reason is because we want to add, we can lay those two rows out without adding any other kind of clickable buttons. So yeah, it's just the same widget, but the logic needs to be different for the third row and the last row, because we need this caps lock and the backspace. So we are only doing this for the first two rows. We show these key widgets. This is what's responsible for painting each of these characters, making them clickable. So it's just a container, it's tappable, has some margin and some radius, and the text value. So when you tap on this, it just calls the on-tap callback that you specify with its value. That's what the key widget does. And right now we're not doing anything inside of that on top. So this is the first place that we want to do something here. But before that, let's walk through the other parts of the UI for the keyboard. The third row has the caps lock key. This is just a widget that has a Boolean state active, and depending on whether it's active or not, it shows a different kind of icon, as you can see, and it has a different color as well, and has an on-tap callback that is called, when it's clicked, it's tappable with the gesture detector as well. And in the on-tap is when we toggle caps lock by making all of the characters uppercase or lowercase to disable. So in third row, we have the caps lock key. We have the rest of the key widgets, which are the other characters in the key on the keyboard, and then we have the backspace key. So this is just an icon inside of a container that is tappable. So this is the on-tap callback that we have to implement by deleting stuff from the controller. So we'll get to that soon. And then on the last row, we have another key widget, which is this, that shows 1, 2, 3 or ABC, depending on what the state is. And there's a space bar that is supposed to add space to the text field. Okay, so let's implement that functionality. Let's add this functionality in here, make these things functional when you click on them. So for the key widgets, there are 2 places I'm using the key widgets, actually 3 places. So let's make this a function, a method here. I'll call it add character. It will take a character and append it to the controller. Okay. Just so that I don't have to read this controller from the widgets every single time, I will create a getter here. So we don't have to have widget.controller all over the code. And so what we want to do is append this character to the controller's text. So controller, the text, we get the current text from the controller, and then we append character to it, and we set the controller's text to that. You would see, why not just do plus this, and you'll be right. But the reason I'm doing that is because we also want to set the cursor position. Remember, the same thing that happened when we are dragging to apply suggestions will happen here if you don't set the cursor position. So we set the controller selection from position here. And we want our text position to be the length of the new text. So this is what we want to trigger whenever we tap on any of the key widgets. It takes in a character, appends that to the controller's text, and sets the cursor to its new position where it should be. So I can just put add char everywhere for the key widgets. Yeah. And so if we start typing here, okay, let's hot reload. Yes. Oh, something is wrong. Okay, yeah, that's because of this. We are not supposed to be appending this again anymore. We just need to set the controller's text. Okay, so that's some progress. The next thing we want to do is make the backspace functional. So what we want to do when we click on backspace is we want to delete the last character that you typed in, that was typed into the text field, right? I'm going to also copy that code and paste. So we only want to do this if there is some text in the text field. So if the controller's text is empty, then there's nothing to remove with the backspace. Otherwise, we grab the text from the controller, and we want to do a replace range. We want to call replace range on that text. Basically, take out the last character in the text and replace it with an empty string. And this is what that looks like. So we find the length of the string, and then we set this text to this, replacing the last element or the last character in the string with this character. And we close that off by setting the cursor position. Now we click on backspace. Yeah, that works. Okay. So the last piece of functionality that we need to add is for the space bar. So when we tap on space bar, we want to add white space. And that's really just calling add character with your white space, with an empty space. Yes, and this is it. All right, so one more thing to note is that if you notice, if I just start typing into this, the text field is not focused. So we want to focus the text field whenever we type something into it, if it is not focused. And to do that, we are going to need to pass down a focus node from the keyboard demo page. So we create it here. We pass it to the text field, and we also pass it to the keyboard widget. Focus node. I will dispose it here. And pass it to the text field. So the keyboard widgets needs to be modified to take in a focus node. It will complain for now, but yeah, we will make that correction. Yes. So we specify another constructor parameter that we need to pass to the keyboard. And yeah, we no longer have that red squiggly line. Okay, so what we want to do whenever we add a new character is check if the focus node of the text field, if the text field has focus, and if the text field doesn't have focus, we request focus. So if the focus node doesn't have focus, then we request focus. We'll hot restart. And then, yeah, now we have focus. We can see the cursor. Okay. Now we get to the part where we need to modify the custom editing controller to be able to retrieve multiple suggestions for our keyboard, because as opposed to the inline one where we show only one suggestion, on our keyboard we have more space, we have more real estate, screen real estate, so that we can show at most 3 suggestions, right? So here I will create another value notifier whose value will just be list of strings. It will be empty for a start, and then we will modify this listener. So in here, we also, I'm feeling quite parched. So in there, we also add those suggestions to the list. Okay, what that looks like is this. Another value notifier. I will call this multi-suggestion notifier. Okay, and we expose this. We expose a getter for this. Right, let's dispose this too. Okay, so here I'm just going to grab the first three suggestions from the list, and yeah, you can decide to randomize here as well, but I will just grab the first three. So suggestions, I think three. So if we have less than three, this is just going to take whatever we have. But if we have more than three, to just take three at most. Okay. Now that we have this, the next thing to do, you can notice how we have inline suggestion happening inside here when we only want to have the keyboard one. This is something that we'll fix later. For now, in our keyboard, we need to add a notify, a value listenable builder to listen to this multi suggestions notifier, so that whenever we get suggestions, we can show them on top of our keyboard. The value listenable, yep. Oh, okay. I need a builder, not just a widget with a child. Okay, grab the suggestions. We don't have a child. All right. So we want to show those suggestions at the top before before this row of texts of clickable buttons, right? So we want those suggestions to be at the top, maximum of three of them. I'm going to copy the code for that. So we already have this widget called suggested text, which is a button with a vertical divider if we want to show the separator. So we want to show the first suggestion, a vertical divider, the next one, and another vertical divider, and then the last one, if there are three of them. So that's what we have here. Right. And we are showing the suggestions. There's an on-tap callback for when you tap on any of the suggestions. So when you tap on any of the suggestions, what we want to do is add that suggestion, just the same way we are doing add character. Okay, so if I hot restart this and go over here, yeah, we see the suggestions coming up. Mm. All right, I was trying to recreate this. It doesn't show up on each key press because we're not listening to the suggestions notifier. But whenever there's any other thing that triggers states change, you will get that. You will see it. All right, so we're getting our suggestions and we're showing them um, in the keyboard. The next thing we want to do is make these things actually apply those suggestions. So when we click on these buttons, we want to append the suggestions to our text field. And it's going to be different from adding a character because it's not just we want to the same way we did apply suggestions on the custom editing controller when you drag to apply the suggestion, where we grab the substring of that entire word that is suggested and append it to the prefix that is typed into the text field. That's what we want to do here. But because these suggestions here are different from the inline ones in that the ones inline, we only paint the part of the word that is not already typed. So when you drag to apply it, we just add that suffix of the word and that becomes the entire thing. But here we have the full word. We don't have a substring that we need to apply. So we need to do that substring computation and then apply what's left to our text field. So that's why we cannot use add character. We need a different function for that. So I'm going to create a new method called add selection or suggestion. We don't need to worry about focus node because if we have suggestions, then it means that our text field already has focus. So what we want to do is grab the last text and then do some substring magic and append it. And what that looks like is this. So if this is empty, if this suggestion is empty, then we just want to return, although we'll never get a case where the suggestion is empty. And then we grab the last text from our controller and do the substring. So we want to append the substring of this suggestion from where the last text of our controller ends. So for instance, here where we have HE in the text field, if I click on heap, I only want to add AP, so it will take the substring of heap, cutting out HE and only adding AP to my text field. And so that's what this does. And we also setting the controllers, the cursor's position as well. So here in the on top of the suggested text, I will call add suggestion. And then if we hot restart this and try again. What just happened? That's an interesting situation. So maybe we want to, yeah, let's fix this. It looks like the autocomplete is broken because anyway, what we want to fix is this. So even if you have right now it's actually doing both autocompletion and spelling suggestion or spelling corrections, which is nice. I did not plan for it to do this, but here we are. So instead of we want to do something more than just applying substring. So we need to check if this text is if it is longer than the suggestion. If it is longer than the suggestion, then it means that we have to replace the entire text with the suggestion. So if this is greater than this, then we do something different. Otherwise, we do what we already have here. So I need to create this text above, right? So we want to take out this text entirely. We don't want to just append the substring of the suggestion to it. We want to remove it entirely. One way to do that is that we can yeah we can keep track of these splits in a different variable and then do a join after taking out the last word from it. So that will be text split, remove last, and then text equals text split the join. And we set the controller's text to that. Okay, so let's try this again. Going to controllers, this dot join, then add the suggestion. Yes. There we go. Yeah, it's not considering the space. So I'm just going to add this to the list and do the join. Another way to fix that is to use string concatenation here. So that would be something like this. And then with this space, then add your suggestion. Maybe we should just do it that way. Yeah, instead of doing this list operations. Right. It does look like it is adding a leading space. Maybe I shouldn't worry too much about this. Yeah, it is adding a leading space. I think that's because of this. Yeah, that is because of this. Okay, so this might actually be the best thing that we need to do. Right. Okay. All right, so we've just discovered that this actually also does spelling corrections based on the data sets that we have in our trie. So that's something, that's a good discovery. And yeah, I think the last thing that we want to do is to fix this inline, the inline suggestion for our whenever we're doing the keyboard demo. So we only want to use the suggestions at the top here. And one way that comes to mind is to just make this opt-in. So users of the custom editing controller can opt in to show suggestions inline. So that would be something like this. So we can make it true by default. And then inside of here, we check if we want to show inline suggestions before we do this. Okay, maybe we don't want to. Yeah. All right, so if I hot restart, nothing should change. Everything will work the same. But in my keyboard demo page, I can opt out of this show inline suggestions. And I will stop seeing inline suggestions for the keyboard demo page. Yeah. I want to fix this periodic flash of the suggestions in the keyboard. And how I will do that is whenever the suggestions from the controller, whenever they are empty, I will just default to a list of 3 empty strings. Okay. So that will be, let's make this data, and I'll create a new list of strings called suggestions. If the data is empty, what I want to do is just generate a list with 3 items that are just empty. And if I run this again, yeah, we'll always see this. There won't be flickers anymore. I mean, the suggestions flicker, but the size of the keyboard won't drastically change on and off on every key press. Okay. I think this is looking good so far. we should still have our, yes, we still have our inline suggestion, and yeah, everything works great. I'm not sure I'm missing anything. Right, so that's actually the whole of this. So to recap, what we have seen is how to add autocomplete suggestions to our text field. And we can do this inline by extending the text editing controller and using a trie data structure to store a data set of strings, which we can look up effectively to do things like autocomplete suggestions and spell check corrections as well. But here we're just doing autocomplete suggestions. We also have two different notifiers because we have different demos in this for this episode. The inline demo uses just one notifier that suggests a single suffix to whatever text that you have in your text field. And then this one, the last one, the multi-suggestion notifier suggests at most 3 suggestions for your keyboard, the custom keyboard that we built. So this gives you an idea of how autocomplete works on your smart phones, and also shows you how you can build something like this for the inline one in your applications. So you would want to have you probably won't need to do this heavy lifting that I've done here, creating a trie, going to look for a very huge data set of text that contains so many words, and then doing some pre-processing, cleaning it up and putting it in your trie. You probably won't need to do this because you would most likely have a trained large language model that knows how to figure out what string should come after another string, or what word chunks, what chunks of words should come after each other. You can take this a step further. Maybe I will add a link to a branch in the repository where you can see where I took it a step further to try to do something like guessing what the next word will be, because right now it's only auto completing whatever whatever you're writing. So incredulous is already a word, and then you've entered an empty space. You're not getting any suggestions. It's because it's waiting for you to write something and then to tell you what you might want to autocomplete, and like what you might want to apply as a suggestion. But even at this, we may want to allow AI or something smart to guess and allow us to write whatever emails, texts, could be anything that your app is doing, based on user data, based on known interaction of people. There's some words that are known to follow each other. So you won't be doing this with a trie. You'll be doing this smarter with a large language model. But you can see something that tries to mimic a large language model with a trie in a branch that I'm going to put a link to that in the description. So yeah, I hope you enjoyed this episode. You're seeing more things that we can do with the text editing controller. Yeah, that's all for now. Thank you for watching. Catch you in the next one.